In this video, we are going to see three page replacement algorithm. First in, first out, optimal page replacement algorithm, and then least recently used page replacement algorithm. First, we have to understand what is a page fault first. A page fault happens when a running program accesses a memory page that is mapped into the virtual address space but not loaded in physical memory. Since actual physical memory is much smaller than virtual memory, page faults happen. In case of page fault, operating system might have to replace one of the existing pages with the newly needed page. Different page replacement algorithms suggest different ways to decide which page to replace. The target for all algorithms is to reduce the number of page fault. First, we will see first come, first in, first out page replacement. This is the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all pages in the memory in a queue. The oldest page is in the front of the queue. When a page needs to be replaced, page in the front of the queue is selected for removal. So the oldest page is going to be removed. That's it. Here we have an example to understand the first in first out algorithm. We have a reference string and then number of frames, number of page frames. Here in this example we have page references 3 2 1 0 3 2 4 3 2 1 0 4 and the frames available here is 3. So first we will take 3. Now since this is the beginning, the page frames, all the page frames are empty, so 3 is brought into the main memory. So since this is a empty frames, then since this is a empty frame, 3 is brought into the memory, so this is a miss page fault. And then 2, next page needed for memory is 2. So 2 is not available, 2 is brought into the memory, primary memory, so there is another miss. And then page 1 is needed, 1 is not available in the frame, so 1 is brought into the primary memory, so there is a third miss. Now 0, the next page needed is 0. 0 is not available in the primary memory, so we need to replace some of the pages, either 1 or 2 or 3 from the main memory and replace the 0 in that place. So here 3 is the page which is brought into the memory first. So we are going to remove 3 and replace 3 with 0. Okay, so since 0 is now not available here, this is a page fault. And then next page needed 3. Next page needed 3. So 3 is not available in the primary memory, so we have to replace 3 with some other pages. So 2 here in this page 1 2 0, here 2 is the oldest page, 2 is the first page that is brought into the memory, primary memory, so we have to replace 2 with the required page 3. Okay, there is a miss, there is a page fault. And then 2, next page is 2, so 2 is not available in the primary memory, so we are going to replace 1 with page 2 because 1 is the first page brought inside the physical memory within these 1 3 0, so we are going to replace 1 with the page 2. And then 4 is not available, so we are going to replace 4 with 0, so there is a miss. And then 3 is already available in the physical memory, so it's not a page fault, so it's a hit. And then 2 is also available, 2 is already available in the primary memory, so there is no need to replace, so it's also a hit. And then 1 is not available in the primary memory, so now we have to replace the first page brought into this primary memory. Among these 2 3 4, 3 is the first page is brought into the memory, so we are going to replace 3 with page 1. So since this is a page fault, it is a miss. And then 0 is not available, so we are going to replace 2 with 0, so because 0 is the first page brought into the main memory among these, so since this is a miss. 4 is already available here, so there is no page fault. So as we can see, the number of page fault here 1, 2, 3, 4, 5, 6, 7, 8, 9. Total, in total 9 page fault. So here we have to understand another one, which is Belady's anomaly. Belady's anomaly proves that it is possible to have more page fault when increasing the number of page frames while using the first in first out page replacement algorithm. We'll use the same reference string but with the 4 page frame. Same page references but with 4 frames. Here first we need to place, we need a page 3. 3 is not available. Since this is an empty frame, 3 is not available, so there is a page fault. And then 2 is not available, there is a page fault. 1 is not available, there is a page fault. 0 is not available in the primary memory, so there is a page fault. Now 3 is needed. The page, next page needed is 3. So 3 is already available in the primary memory, so there is a hit. There is not a page fault. And then 2 is already available in the primary memory, so there is no page fault hit. And then 4 here, 4 needed, so 4 is not available. So first page brought into the primary memory here is 3. So we are going to replace 3 with 4. So there is a page fault. And then 3 is not available, so there is a page fault. So we are going to replace page 2 with page 3, because among these 0, 1, 2, 4, 2 is the first page which is brought into the primary memory. So 3 is replaced with page 2. There is a miss. And then 2 is needed, 2 is not available, 2 is replaced with page 1, and there is a page fault. And then 1 is not available in the primary memory, 1 is replaced with the page 0, there is a page fault. And then 0 is not available here, so it is replaced with 4, and then there is a page fault. And then 4 is needed, page 4 is not available in the primary memory, so there is a page fault. We are going to replace page 4 with page 3. So as you can see, number of page faults here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see the page fault is 10. So increasing the frames will not decrease the page fault. That is Belady's anomaly. In the next algorithm, we are going to see optimal page replacement algorithm. In this algorithm, pages are replaced which would not be used for the longest duration time in the future. So what we are going to replace here, page which are not going to be used in the future. That's what the optimal page replacement algorithm. So we have page references here 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2. And the number of frames 4. Here first we need 7. 7 is not, since this is the beginning, 7 is not available in the primary memory. 7 is loaded. There is a page fault. 0 needed, 0 is not available, so there is a page fault. Miss. And then 1 needed, 1 is not available in the primary memory. 1 is placed in the primary memory, so there is a page fault. 2 is not available, there is a page fault. 2 is brought into the primary memory. Then 0. Next page 0 is already there, already is loaded in the primary memory, so there is no page fault, it is a hit. And then 3 needed. Now 3 is needed, so we have to brought 3 into the primary memory. Now we have to replace 3 with any of these pages. Now what we are going to replace here, the page which is not going to be used in future. Here 2, here this is 3, 2 is going to be used in 0, 4, 2, 2 is going to be used. 1 is not there, 1 is not going to be used. 0 is again 0 is already going to be used. 7 there, 7 is also not going to be used by the in the 7 is not also going to be used in future. So here we have 2 pages, 1 and 7. So we have 2 pages available, so here we use first in first out. Whichever the page, whichever the page comes first, here we will remove the page and replace with the 3, because we have 2 pages that are not going to be used in near future. So we will remove the first page brought into the memory 7. So there is a page fault. And then 0, 0, page 0 is needed, page 0 is already there, so there is no page fault. And then 4, 4 is not in the primary memory, so we have to replace 4 with some other pages. 2, 1, 0, 3. So 2 here, 2 is going to be used here, 1 is not going to be used, 1 is not going to be used in near future, 0 is also used here. So the page which is not going to be used here in future, 1. So we will replace 1 with page 4. So there is a page fault. And there is 2, page 2 is already in primary memory, so there is no page fault. And then 3, page 3 needed, page 3 is already available in the primary memory, no page fault. And then 0, page 0 is already available, no page fault. And then 3, 3 is already available, no page fault. 2, 2 already is available, and there is no page fault. So the number of page faults here, 1, 2, 3, 4, 5, 6. The total number of page fault, 6. Since optimal page replacement algorithm is perfect but not possible in practice, as the operating system cannot know future requests, the use of optimal page replacement is to set up a benchmark so that other replacement algorithm can be analyzed against it. So next algorithm we are going to see least recently used page replacement algorithm. In this algorithm, page will be replaced which is least recently used. In optimal recently algorithm, page is replaced which is not going to be used in future. In least recently used, the page will be replaced with least recently used here. So in optimal, we have to see forward. In least recently used, we have to see in reverse. So we have page reference string and the number of page frames 4. So these are the page references. Same question 7 0 1 2 0 3 0 4 2 3 0 3 2. In that order, we are going to reference these pages. These pages are needed in primary memory. Same number of frames 4. Now we are here 7 is not available in the primary memory, so there is a page fault. And 0 is not available, there is a page fault. 1 is not available in primary memory, there is a page fault. 2 is not available in the primary memory, there is a page fault. And then 0 is already available in the primary memory, so there is no page fault, it's a hit. And then 3 is not available in the primary memory, so we have to replace the page which is not recently used here. So the page which is not recently used here, 0 is already, 0 is used right just now. 2 is already used, 1 is used, 0 again, 0 is referenced. 7 is the page which is least recently used. 7 is the page which is least recently used. So we remove 7 and place 3 in that place. So there is a page fault. And 0 is already there, so there is no page fault. 4, now 4 is not here, 4 is not available in the primary memory. Now we have to replace 4 with any of these pages. Now we are using least recently used, so now the page to be replaced is least recently used here. 0, just now we have used 0. 3 is used just above. And then again 0, 2 is used. So the page 1 is the page which is least recently used among these 4 pages. So we replace page 1 with page 4. So there is a page fault. And then 2 is already available in the primary memory, no page fault. 3 is already available, no page fault. 0 is already available, no page fault. 3 already available, no page fault. Then 2 is already available, there is no page fault. So the number of page faults here 1, 2, 3, 4, 5, 6. So total page fault 6. So since this is a same question, in this question gives same amount of page fault using both least recently used algorithm and the optimal recently used algorithm. If the question changes, the page fault will also changes here. So here that's it for page replacement algorithm. In the next video, we will see further topics.